Morning, everyone. I'm going to be taking you through artificial intelligence. I'm using this template that is Kawanga Marvin, and it's presented by Natunda Catherine, Makerere University. I'm taking you through artificial intelligence mainly in the restaurant where I'm talking about restaurant order picking. How is this going to help us? We are trying to use artificial intelligence to solve the daily problems that are affecting us, such as the poverty. And how does poverty come about? Is because of the various many simple problems that we ignore, such as the service deliveries and restaurants, which decrease our incomes. Plus, they affect the GDP of our country. The GDP growth of our country is actually somehow static because we are ignoring just small problems that we should have solved to have Africa world with no poverty. And so I'm using the data set from Tomato Concrete Data and LSTM model. As the link is here, you can follow it up. In this data set, it's able to give me to rate for me the different orders that I can be taking in a day. It gives the rating and everything. So it's a good data set to go for. And why would I go for it? It's because it's ability to generate the feedback, because everything you do, you must be able to generate the feedback from the customers and even other people, and its ability to give accountability, like that it marks the orders that someone has taken. It's easy to use and generate accountability. The flexibility of the data set is also paramount. That's why I chose it, because it's able for me the user, to get feedback, and the person who whatever the model can also get feedback. Then there is ability to capture data about the different customers, such as their names. As you go into the link, you'll see how it is very important. These are the important features from the data set. It provides tables. These tables help to summarize the data used in the model, because we do not want confusion. That's why the data set provides tables for easy evaluation of work. The graphs help to predict like a future orders. For example, like my model captures the orders that have been taken in January, and then the orders that have been taken in December. So using the graphs, I will be able to predict the orders I might get in the next month, like that. The relevance of the data in the model. The, the data that are collected in the model has value, and it has its total full integrity. There is nothing like corruption of data. And I'm going to take you through the Bayesian theorem. What do I mean by the Bayesian theorem? The Bayesian theorem states that the conditional probability of an event is equal to the likelihood of the second event given the first event multiplied by the probability of the first event. This Bayesian theory is actually what's the Bayesian theory is the formula for determining the conditional probability, where the conditional probability is the likelihood of the outcome, like the outcome that occurring of an event. In the conditional probability, actually, we look at two things: that's the prior probability and the post-prior probability. This Bayesian theorem is at the times also known as the Bayes' rule or the Bayes' rule, and it's the foundation of Bayesian statistics. This theorem can be used to determine risks that's in finance. For example, in the restaurant finance, I can use it to evaluate the risks are faced with using the model, and it's also used to determine, like, it's actually used in machine learning language. That's why it's more appropriate when I'm using it in this artificial intelligence. It was named in the 18th century behind the mathematician Thomas Bayes, and its formula is just explained here. As we shall see more in the PowerPoint, the elaborations, this is just the probability of A given B which is the same, which is equal to the probability of A intersection B out of probability of B, which is the same as I say, I multiplied by the probability of the first event, which is the probability of B given A out of probability of B. And then up next, I'm talking about the Bayesian theorem. How is it important? It is used in finance, medical society, machine learning, and many others. As I told you, it's used in machine learning, and that's why I actually chose to use it in the artificial intelligence. How is it used in machine learning? It provides a useful method of thinking about the relationship between the data set and the probability, like between the data set you have chosen to use and the probability, the likelihood of that data set to be the best. It's used like it's important. It's often used in calculating risk evaluation, as we saw in the finance. It's useful in implementing machine learning. That one we already talked about it. And what could be the challenges that we can face by using this theorem? It requires high volume of calculation capacity to execute its transaction. That's actually the main problem that we face using this theorem, otherwise it's a good theorem. And it depends on a certain factor, that it depends on prior probability to generate a posterior probability. Like it depends on the current event to predict what might be the occurrence after some time. Let me give you an example, like today's order and my current event. Then it will use these current events of today, 1st November, to predict, let me say that the likelihood, the events are like the orders are likely to take place tomorrow, like on the 2nd of November, using the current probability that I might generate from today. It actually works together in hand with the naive bias. What is actually the naive bias is a supervised algorithm. As I talked about in my last video, you just need to subscribe and follow up what I talked about, the supervised algorithm. It's based on it, and it's based on the Bayesian theorem, and it is used for solving classification problems. It's mainly used it mainly uses the text classification that includes high dimensional training data sets, and it's a probabilistic classifier. Like it classifies the probabilities, like to what extent. For examples of a naive are like a span filtration, the sentiment analysis, and many others. Why is it called naive bias? It actually these are two words. Naive because it assumes the occurrence of a certain feature is independent of the occurrence of other features. Like when I'm taking the occurrence of today, it's totally independent from the occurrence of others that happened yesterday. That's why it's called naive. And it's called bias because it depends on the use of the bias as I talked before. Steps to follow when you're using these bias are you convert a given data set into frequency tables so as you eliminate the confusion. You generate the likelihood table by finding the probabilities of a given features and use the Bayesian theorem to calculate the posterior probability, because we talked about the Bayesian theorem is to use the prior probability to estimate the upcoming probability, the posterior probability. There are many types of naive Bayesian on the website, the multinomial and binomial. The Gaussian assumes that features follow a normal distribution. Like it's a normal distribution, so we do not expect like continuously, it's a normal distribution. And then this one is used for data that is multinomial, distributes like that is multinomial. And this one is just similar to the nominal classifier, but the predictor variables are the independent binomial variable. Continuation of the Bayesian theorem, it has an assumption for it to operate. It has an assumption that states that the independence among predictors. It's naive, it doesn't It doesn't depend on anything for its operation. Advantages: it works more efficiently than any other iPhone. It's fast and easy to implement. It's highly scalable, sensitive towards irrelevant features, so you have to be careful because it's really sensitive, and it's best suitable for text clarification problems as we already talked about it. Like take an example, taking in the orders, and it really helps me to classify the types of orders because they come in as text, as what can handle both continuous and discrete data. That's the best of it. And this is what is Alan is saying. The assumption is hardly true in real life because it's hardly true like the independence among predictors. Literally in my day-to-day, I'm depending on the orders of this study to predict. So when something is independent of that features, it's very pretty hard to use. Here I'm doing the difference between buying naive buyings and the Bolshevian theorem as we already talked about. It's actually very easy to generate. I would not want to go into this as long as you understood the background. It's less complicated because it's easy to use. It has a better performance. It's actually a well-known variable. It's the one that is found well-known that you can search and investigate. And they tell you that all features are considered as up to date. There is no feature that is left behind because we are doing things that are independent. So every feature has to stand. It assures conditional independence. Whatever it decide, just make it decide. And yes, that's it. Here, when we're talking about the difference between Bayes' network and the naive Bayes, we are talking about network. How like we are using it now in the terms of the network, how is it related with here they tell you that it has an entire network and it here it's just implemented in a multi and meaning this is more open than this one to be used, and it's used in solving prediction tasks as we already talked about. It's not suitable, it's less complicated. Data performance on some data sets. Take an example like I have a data set of 15 attributes. It's more easy to use than using this on those large data sets. But it has better performance on some data sets. Yeah, it's less restricted. Finally, these are the references that I use in my work. You can just based on make a little more, but I didn't. I haven't done it because of the time and words. But I wish you would be blessed in the whole day. Subscribe for more advice. We welcome each and every education. Thanks for tuning in.